means creating systems that not only make decisions but also explain them in a relatable manner. This clarity transforms AI from a mysterious black box into a reliable, transparent tool, enhancing user confidence and providing a good relationship between humans and technology. To summarize, XAI is crucial because it ensures that AI decisions are not only effective but also justifiable, making the decision-making process clear and understandable. By fostering accountability, XAI guarantees that AI systems operate in alignment with ethical and societal standards, promoting trust and fairness. Furthermore, XAI transforms AI into a transparent and reliable tool, boosting user confidence and nurturing a positive relationship between humans and technology. Now let's test our knowledge and remember why XAI matters with some exercises. Great work on the course content so far. We will now go over the technicalities of XAI. This will expand our understanding beyond the role of XAI's translator between AI systems and human understanding. Explainability in XAI is a flexible concept. What is clear to one might be vague to another. Let's say we are using an AI system for credit scoring, and we are denied a loan. A statistician might be able to interpret the percentages of how each feature contributed. For instance, Let's say we are using an AI system for credit scoring, and we are denied a loan. A statistician might be able to interpret the percentages of how each feature contributed. For instance, the credit history contributed 18% in denying a loan, and the debt-to-income ratio contributed 40%. For someone else, this might be less straightforward, and a more visual representation is more understandable. For someone else, this might be less contributed 18% in denying a loan, and the debt-to-income ratio contributed 40%. For someone else, this might be less straightforward, and a more visual representation is more understandable. While the goal of XAI is admirable, it's important to recognize its limitations. Certain advanced AI models, particularly in deep learning, are inherently complex and resist interpretation. A complex model in AI is also commonly referred to as a black box model. A black box model in AI is a type of model where the internal workings or decision-making process are not visible or easily understood by humans. It's like a complex machine where you can see what goes in and what comes out, but not how the machine processes the input to produce the output. For each model that we use, there is a trade-off between the performance and the explainability. In exploring the balance between model performance and transparency, it's crucial to recognize that not all powerful models sacrifice interpretability. While it's true that advanced, intricate models often achieve higher accuracy, this doesn't invariably make explainability a casualty. Sacrifice interpretability. While it's true that advanced, intricate models often achieve higher accuracy, this doesn't invariably make explainability a casualty. In fact, certain modeling techniques may offer slightly lesser accuracy but significantly greater interpretability. This nuanced trade-off highlights the importance of decision-making in XAI. Explainability a casualty. In fact, certain modeling techniques may offer slightly lesser accuracy but significantly greater interpretability. This nuanced trade-off highlights the importance of decision-making in XAI. Choosing the right model involves weighing not just the need for precision but also the value of understandability. Understanding when and how to make this trade-off is a pivotal aspect of mastering XAI, ensuring we harness AI's power without losing sight of its workings. XAI strives for explainability through two primary avenues. On one hand, it utilizes inherently interpretable models such as decision trees and linear regression. These models are transparent by design, offering clear insights into their decision-making logic, in stark contrast to the opaque nature of black box models. With interpretable models, each step of the reasoning process is traceable and understandable. On the other hand, for models that are not intrinsically interpretable, XAI employs specific techniques to shed light on their decision-making processes. Techniques like Shapley additive explanations, and LIME, local interpretable model agnostic explanations, are pivotal in this context. They provide estimations of a model's reasoning without altering the model itself, enabling us to interpret the decision-making processes of otherwise opaque models. These methodologies will be explored in greater detail in the following chapter. Additive explanations and LIME, local interpretable model agnostic explanations, are pivotal in this context. They provide estimations of a model's reasoning without altering the model itself, enabling us to interpret the decision-making processes of otherwise opaque models. These methodologies will be explored in greater detail in the following chapter, highlighting their role in making complex models more transparent and understandable. Now that we've acquainted ourselves with the key concepts and terminology of XAI, it's time to put this knowledge into action with some engaging exercises. Remember, XAI is not just about understanding AI, it's about making AI understandable to us. Excellent progress. Let's now explore communication about explainable AI. Part of making AI explainable is making AI systems understandable to diverse audiences. Effective communication in AI starts with audience segmentation. It's essential to tailor language and presentation based on the audience's background. For technical audiences, delve into the specifics of algorithms and data. For non-technical groups, highlight AI's practical impact and applications. Let's consider explaining a recommender system to different audiences. In explaining a recommender system to a technical audience, we would focus on the specific algorithms and data models used. For instance, we might discuss collaborative filtering techniques, matrix factorization, or neural networks. We delve into how these models analyze user behavior data, item characteristics, and interaction patterns to predict user preferences and recommended items. We'd also discuss the system's scalability, performance metrics, and how it handles issues like cold start or sparse data. When explaining a recommender system to a non-technical audience, the approach is more about the concept and its impact. For example, we might compare the recommender system to a knowledgeable friend who suggests movies based on what we've enjoyed in the past. This system analyzes what many people watch and what we've particularly liked to recommend movies we might enjoy. The focus would be on its practical use, like how it makes finding movies easier and more personalized, rather than the technical workings. Simplifying complex AI concepts is key. For example, to explain a neural network, use analogies like how a human brain processes information using neurons. This approach makes the concept relatable and easier to grasp. Visual aids, such as flowcharts or infographics, are powerful in demystifying AI. For instance, a simple diagram can effectively explain how a decision tree makes predictions. These visual tools aid in clarity and understanding. Storytelling can bring AI concepts to life. A narrative about how AI improves daily life, like smart assistants optimizing schedules, can make the technology relatable and tangible. However, while simplifying concepts, it's crucial to maintain accuracy. Oversimplification can lead to misunderstandings. Our goal is to provide clear, accurate explanations without sacrificing the truthfulness of the information. Finally, be aware of potential misinterpretations. Clearly explain the limitations and uncertainties of AI models to set realistic expectations. Transparency builds trust and fosters a deeper understanding. An example of an accurate and simplified example would be: machine learning is a type of AI that allows software applications to become more accurate in predicting outcomes without being explicitly programmed. It works by using algorithms to analyze data, learn from its patterns, and then make a decision or prediction. Think of it like teaching a child to recognize animals. By showing them many different pictures and telling them which animal is which, they learn to identify them on their own. An example of an overly simplistic explanation would be: machine learning is like a computer playing a guessing game. It makes guesses about what you want based on your past choices. Just as a child learns to guess the correct answers over time, the computer learns from your choices to make better guesses in the future. It's as if the computer remembers what you like and don't like, using that information to make smarter guesses next time. Now that we've taken a look into communication about AI, time to engage with some exercises to solidify our understanding.